Good afternoon, everybody, and welcome to our second session of the day. Really excited to be joined by Jen Openshaw from BAE. We'll be well, I'll let Jen do the intro of what the talk's going to be about, but as ever, if there's any questions, let us know in the chat throughout. We'll make sure that they get asked either during the session or at the end. If you're watching retrospectively, put it on Discord, and I will share now the hub info so that you can follow BAE Systems for all the latest updates, all the latest stuff, and some career opportunities on there as well. So I'll pass over to you, Jen, and yeah, enjoy everyone. Let us know if you have any questions.
Brilliant. Thanks, Alex. It's really lovely to be here. We're so pleased to be part of Athena again this year. My name is Jen. I'm a software engineer at BAE Systems Digital Intelligence, which is the cybersecurity division of BAE. I'm based up in Manchester, where we've got a nice new office in the city centre. I'm a software engineer now, but I didn't start off as a techie person at all. I did history, French, English literature at A-level, history at university. And it's only a bit later on that I've changed careers and gone down a much more techie route. I had a completely different job before. I worked for the National Trust, so like old buildings, countryside, that sort of stuff. And then when I was on a career break raising my two young boys a couple of years ago, I decided it was time for something new. I found a part-time coding course up here in Manchester with a school called Manchester Codes. It was a part-time boot camp, really, and did that for 6 months and then got a job as a software engineer with BAE Systems off the back of that. That was about a year ago, and I'm now a junior developer and haven't looked back since. So today I'm going to be talking to you about emojis, how they work and how they support diversity. And we'll be talking a little bit about character encodings and some of the tech that goes on behind emojis, as well as how they contribute to social change. So right from the start, I'm going to ask you to be a little bit, to get your brains into gear. So have a think for me. Computers. What are some things that computers are bad at? Just have a think. I'll give you a few seconds. Jot it down if you've got a pen and paper. Pop it in the chat if you like, or just keep it in your head. Okay, I'm sure you've got some ideas. Here's what I put down. So computers are bad at emotions. Computer doesn't care if you're happy, if you're angry, it's going to treat you the same way. Uncertainty. Computers aren't great if you give them unclear data. Social interaction. You can't treat computers like you treat people. You don't get the same back, do you? And language. It doesn't understand human language, a sort of combination of the above, the sort of phrases that we use, idioms that we use every day. It's not great at unpicking those. So next, what are some things that computers are good at? On the other side, again, I'll give you a few seconds to jot down your ideas. This is what I put down. Numbers, just that. That's pretty much it. We know that computers are good at numbers and bad at most other things. So with computers, it all comes down to numbers, right? And you'll probably immediately start thinking, oh yeah, binary. I know about that. Zeros and ones. Computers are all about binary, zeros and ones, numbers. That makes sense. So we're going to sort of think about it at a level slightly above that. So when we want to use words on a computer, we know that we somehow need to turn those words into numbers so that the computer can work with them at a really basic level. So we're going to have a go at that first in a really simple way. First, let's try letters. So let's try turning letters into numbers. So you can see on the screen now, there are letters A to Z across the top, and we've assigned them a number. So A is 1, B is 2, C is 3, etc. So far, so easy. So let's try and decode a word here. So again, in your own time, either with pen and paper or just in your head, what numbers would represent the letters for the word Athena? That's it, great. So I'll start you off. A is 1. So T, if we look at our line above, is going to be 20. H will be 8. E is 5. N is 14, and A is 1. So taking the letters, and we've turned them into a numerical code. Dead simple. So let's do it backwards. Let's decode this time. I'll give you a few minutes. Who can decode this word using the line above? Great, well done for those of you who've got there. So the answer is empower. So that's what we'd call in the computer world character encoding. It's a way of turning letters into numbers and vice versa. So here we've got the capital letters. So what's missing from here? So say we wanted to send, I don't know, a WhatsApp message. We would, for a start, want to have lowercase letters. We don't just do everything in uppercase letters, of course, unless we're using shouty capitals, which happens sometimes. And we're also missing punctuation and spaces. There's a space, look down there, number 59. It's quite hard to write a message, right, without any spaces. So here we've got like a slightly expanded character encoding, and this is where we are introduced for the first time to ASCII, the American Standard Code for Information Exchange. So back in the 1960s, people were inventing different ways of allocating these numbers. So like we've just done A to 1, B to 2, in some other part of the world, they might have done A starts at 20, B is 21. So all around the world, people were inventing different ways and they weren't talking to each other. So that was fine before the internet was invented. But when the internet was invented and computers started to be connected, it starts to become a problem. This is where ASCII comes in. It was invented in America. It really caught on, and it's what we still use today. So all computers around the world recognize this standard. They all use the same standard. So it means that, in one part of the world, A is a particular number, and in another part of the world, A is also that particular number. It just removes that confusion. So you remember we had 1 for capital A. Well, if we take a look at the ASCII standard chart, which I'll bring up in a second, we'll find a capital A. So if you have a look at your screens, it's in the middle there, second one down, and it's 65. So instead of 1, according to ASCII, they use a 65. So, whether it's your smartphone or your iPad or a wearable like a Fitbit or something, Alexa, they all know that capital A is 65 because they all use ASCII. So the eagle-eyed among you will notice that this starts at 32. So what happens with 0 to 31? Let me bring them up for you now. So these are called control characters. We don't need to spend too much time on these, but basically they allow computers to send other types of information. So look at number 7, for example, bell, B-E-L. So that tells the computer to make a ding sound. So, I guess, quite important when you're inventing ASCII in the 70s, who knows? So we're going to move on to briefly talk about hexadecimal. That's a good word, right? Coming from a non-techie background, the first time I saw the word hexadecimal, it meant nothing to me. And now if I throw it into conversation with my family, they think I'm super techie and impressive. Not that it comes up much in conversation. So what is hexadecimal? Let's break it down a bit. We know from school, right, that hex means 6, like hexagon, and des or decimal means 10. So simple as that. We add 6, we add 10, and we get 16. So hexadecimal literally means 16, just like hexagonal means 6 or octagonal means 8. So when we were looking at ASCII just now, all of the codes were made up of numbers. But it turns out that computers also use some letters to make up the code too. Remember, I'm talking about the level now between binary and what we see on the computer. So it also uses the letters A to F. So if you look at the hexadecimal code, we've got numbers 0 to 9, and then we've got A to F, which just means that instead of using a combination of numbers, we use a combination of those 9 numbers and those 1, 2, 3, 4, 5, 6 letters. So here's an example of some hexadecimal codes. So 2A, FF3E9, and BADFOOD, which looks like bad food. So when we're using hexadecimal codes, we also put something in front of them, which means that anyone reading this knows that it's a hexadecimal coming, and that's this 0x, which tells you that it's a hex code. That's all it's saying. So it turns out that ASCII also lets us use hexadecimal this way too. So let's have a look at that in action. Okay, so here's an ASCII chart with those hexadecimal codes instead. So we'll do the first one together. Let's decode this word like we did, but with the hex code. So the first one is 0x48. So remember, we know that 0x is just telling us that there's a hexadecimal coming, so we can just ignore that. And then we go to 48. So we look up 48 in the chart and we can see that it's an H. So have a go at working out the rest on your own. Remember to ignore the 0x and then find the code in the chart on the right-hand side and see if you can work out what this word spells. I'll give you a few seconds to do it. Okay, well done. Yeah, so it says hello. And an extra well done for those of you who spotted that the final letter is actually a 0. Sneaky, that one. So ASCII is what most computers have used to make text for the last 50 years. But there's something seriously missing from ASCII. Here is a clue as to what that might be. So as you can see, non-English characters have appeared around the screen. So the ASCII standard is extremely English-centric. Most other languages have other characters that just aren't included in ASCII. Has anyone got any idea what percentage of the world's population has English as a first language? It's about 5%. Certainly lower than what I imagined before I heard that stat. And if we broaden that to people who speak English, it's still only about 20% of the world's population. So we're in this situation where all of the world's computers use ASCII standard, but the ASCII standard doesn't apply to non-English characters. So a little bit of a problem here. Thankfully, someone decided to fix this, and we're going to move on to talk about Unicode. So Unicode is the common global approach to character encoding. Everyone in the world should be able to use their own language on phones and computers. I mean, that is a given, right? You know, we don't need to say any more about that. So it brings us right back to what this is all about. It's about people. It's about not forcing a foreign language on, or alphabet, or a lack of characters on anyone. So in Unicode, every character gets assigned a unique code. So every one of those non-English characters that we saw. And that's for every alphabet, for every language, modern and ancient. That's the aim. Unicode isn't quite there yet, but it is getting close. So at the moment, Unicode currently supports 143,859 characters. So that is an awful lot more than were able to be previously supported by ASCII. So how does it do this? Well, it abandons the attempts of those previous encodings to squeeze all the characters into, in technical terms, into 1 byte or 256 slots. So the popular way to store Unicode strings uses between 1 and 4 bytes per character. That means it can encode over 1 million different characters. So it gives us a lot more, flexibility. So there are lots of different Unicode charts. It's broken down into different groupings. So you can see, for example, that there's a whole section for all the East Asian scripts and all the special characters it needs for those. There's a whole different section for African scripts and the different characters that we need for those. And if we look near the bottom on the right-hand side, you can see emojis appearing. So we are how long into my talk, and finally we start to talk about emojis. So Unicode became the standard universal way for computers to display language. It took over from ASCII. And in the late 2000s, when mobile phones really took off, and smartphones in particular, emojis became a big part of communication between people. So Unicode got on board pretty quickly and started adding unique codes for emojis to their standards. So now emojis are just like letters. In all those languages, there's one standard way across computers for them to be used and shared between devices and people all around the world. So of all those characters that we just saw, of all those different charts with different languages in, emoji is probably one of the most globally used set of characters. I've seen an estimate that 92% of people that communicate on the internet are using emojis around the world, and over a third of them do so on a daily basis. I mean, I don't know the maths, but that is an insane amount of emojis flying around day by day. So I said that every character in Unicode gets a unique code. This is called a code point. So let's have a look at what a code point looks like. This is how they're written. It's got U plus in front of it to show that it's a Unicode code point, just like we saw 0x for hexadecimal. We use UX for code points, tells us there's a code point coming, and then at least 4 digits afterwards. So there's some more. Here we go. That's a good old emoji there. So you'll notice with the last one that those digits are using hexadecimal. You know, we saw before. So there's 1F4A9. That's using a combination of numbers and letters. And so we know it's hexadecimal. So this has got a lot more digits than the ones above. And this is because Unicode is split into areas and emojis sit up here in this 1F area. So we know that the emojis will live there. So we're going to have a go at some of these in action. We're going to try encoding and decoding some emojis using those code points. So I'm going to pop up a website, and Alex is going to put the link in the chat as well, so you can copy and paste, or if you're on your phone, just scan that smart code. It will take you to a website that's recommended by Unicode as the official website for looking up these code points. You can have a play along as you go. If not, don't worry. I'll be showing you as we go along, so you can follow along with me. So I'll bring up some hex codes on the screen. So some code points, sorry, on the screen. So we are going to go to that website. We're going to try and search for those code points, and we're going to work out what the secret message is that's decoded here. So I have already got the website up. Here we go. So the first one I'm searching for is U plus 0049. So I'm simply going to go to this search bar and I'm going to type 0 plus 0049, hit enter and see what that responds to. Okay, so down here, it's a letter, Latin capital letter I. So we know the first one is I here. So the next one, U plus 2764. 2764. Hit enter. Heart, okay, so we know we're doing I heart something. And then the next one, 1F355. Can I remember that? U1F355. And it's pizza. Okay, well done anyone who was following that along. Let's just check. Yep, it is, and very appropriate. I do very much like pizza, so that's cool. Okay, now we're going to do it the other way around. So instead of searching for those code points, we're going to try and find out what the code points are. So this website lets us search both ways. So first one we're looking for is we want to find out what the code point is for a snowman. I'm going to go back to the website, and in this bar, I'm just going to type snowman. Enter, what it comes up with. Okay, so it's giving me a choice of 3. I can have snowman, snowman without snow, and black snowman. I think snowman without snow sounds likely. See, my Google Chrome is on a go today. A second to catch up. Hope your computers are a bit faster. Okay, there he is. We know that's the right one. So when it finally loads, there we go. So U26C4, we should expect that appear there in a second. A sun. So let's have a search for a sun. Is that going to be the right one? No, it doesn't look like it. Okay, sunshine. So you can already see here, black sun with rays, that's not the one I want either. So you can already see here that it's a bit tricky to identify which one. And here, next, I'm going to search for, what would we call that one? Water, perhaps? Water drop? Oh, droplet. You can see it's already coming up there. So I'm not sure I would have actually thought to search for droplet. But again, it's showing you that there are different ways of describing these things, and we don't know that we're actually getting to the right code. So 1F4A7. So let's reveal the code and see if we found the ones that we wanted. Yeah, okay, cool. So you can see that it works both ways. We can search for the code point and get the emoji, or we can do it the other way around. So one of the problem with having so many symbols is it can be hard to find them, and it can also be hard to make sure that they look similar on different devices or different websites. I don't know if you've ever noticed, but if an emoji on a Samsung device looks different to the emoji on an Apple device, for example. If you've got a Fitbit, I mean, I've got one of these smart watches, and it shows up all of the emojis with a little sweatband across the top because it's a fitness thing. It's just a thing that the developers at Fitbit have put in, thinking it was a fun, it's a fun thing to have. So although you can have the same smiling face emoji, it can look different across different things. Okay, so next thing we're going to do is I'm going to give you a last couple to find. Okay, so we've got a black man waving and a female policeman. So we'll go to our website and we will have a look, see if we can find it. Okay, and nothing's coming up. So there is a reason for that, and I'm going to stop you there if you're already looking. Don't bother searching anymore. So although these two emojis do exist, I mean, we could find them in our phones right now, right? If we go to WhatsApp, we know that those will appear. But the closest codes that we could find on the Unicode website would be the gender-neutral, yellow-skinned version of those emojis. That's the only emoji that has a code point. So it's worth pausing here to consider that even if you or I don't use emojis much, right, personally, a lot of people do. So that source that reported that 92% of the online population use emojis, that means that about 10 billion emojis are sent every day. So given how big a part they play in how we communicate, ought they not be representative of the people using them? Again, it's a no-brainer. Of course they should. So these are I mentioned before, these are the gender neutral versions of these emojis that you would find on the website. So there's this great quote here about diversity in technology. So our children's early experiences, including the hours spent consuming media, shape what they imagine to be possible for people who look like them, live where they live, or come from where they come from. So if you can't see yourself in an emoji, if you can't see in the technology you're using a face that looks like you, we're off to a bad start, right? And up until a few years ago, if you were communicating with someone using WhatsApp or, another example, the only way you could represent someone working for the police was a man. The only doctor emoji was a man. The only family was a man, a woman, and a child. There were no dark skin tones. There was just the one yellow skin tone color that we know emojis are for. And representation is so important. You don't need me to tell you that, right? So Unicode aims to allow everyone to use their own language on their computers and phones. It also allows technology to be physically representative. If a black person wants to communicate how they're feeling, why should it be with a white person's face? If we want to be able to communicate the idea of a police officer, why should it always be a male police officer? So how does Unicode support that? By modifying emojis. So here is a picture of a black woman, I mentioned that there were no code points for the policewoman earlier, no code points for the black person waving. So how do we get to display them? So if we wanted a separate code point for every single combination of gender, skin color, hair color, profession, ability, for every emoji, then that's very quickly going to add up. And there aren't going to be enough code points for them. I know there are an incredible number of possibilities of code points, but there simply would not be enough. So how does it work? How do we use technology to specify a common way to indicate that someone wants to represent a policewoman or a woman with a particular skin tone? Well, what you're seeing on the screen now, this emoji, is not represented by a code point. It's a grapheme. That's a single graphical unit. And you can combine multiple code points to make one grapheme. So for skin tone, the way it works is that you use the base code point. So for a woman, for example, female emoji, then you use one of these skin tone modifiers. So when they appear next to each other, if the system supports it, and most of them do now, it will combine them together under the hood to give you this single grapheme or this single emoji with the correct skin color. So if you take the woman emoji code point followed by a particular skin tone, then what you see on the screen should be a woman with that skin tone. So here's the generic one, here's the skin tone, and here's them combined together. Those are the code points involved for the first two, and that's what it looks like afterwards. Okay, so it's all been very theoretical so far. Let's give it a go. We're going to go to another website now, one that we've created especially for this exercise. So Alex, if you wouldn't mind sharing that link again in the second link in the chat, that would be great. You can also scan it up with the QR code that's on the screen now. And the website that you see should be the little image on the right-hand side there. Okay. So we're going to use this for the rest of the talk now. So I'm going to go to the website. So I've got it open already here. So at the moment, we're just going to be looking at the top two lines. So you can see here that I've got a line of people across the top. So those are the basic generic ones I mentioned before. So we've got a man, a woman, a girl, a boy. There's a gender neutral police person, a construction worker by the look of it, and a couple of superheroes or villains there. And I'm just going to clear this example I did before. And so you can see, for example, that I can make a fair-skinned boy by clicking on the boy emoji, clicking on the skin color, and it's modified it down here. If you scroll down further, you can see here the two different code points that have been used. So there's the boy code point and the skin color modifier code point. Okay, so far so good. We can see how that works. So let's go back to our slides. So multiple code points can be combined using something called a zero width joiner code point to form a single grapheme. Remember, a grapheme is that emoji that has been modified with a different skin color or with something else. So you can see here that we can join the generic police officer with a zero width joiner. That's what this ZWJ is, and with the female symbol. So let's give that a try now. So I'll clear the boy that I had before. So we're going for a generic police officer, a zero width joiner, and the female symbol here. There we go. And you can see she's turned into now a female police officer. So behind the scenes, this is what's happened. We've had the code point for the police officer, the zero width joiner, and then the female sign. Let's go back to our slides. It's showing us that those are the code points we just saw, and that's what we end up with. Okay, so let's try a few. I will bring these ones up. Here we go. And see, I'll give you a few minutes now, if you're on that website, to have a go at creating these emojis and see what you come up with. And we'll go through it together in a moment, but I'll give you a little bit of time to have a go by yourself. If you're not already on the website, the QR code will get you up.
Yeah, and just to add to that, I've added a link to the chat as well. So, and I think if there are any questions around this or anything that's been done, obviously while you're having a go, just let us know. I think while people just to squeeze a question in, I guess, Jen, while people are kind of going through this, well, A, how many times do you try and squeeze the word hexadecimal into a conversation with your family? Because I think that's something that I would like to see as you're trying to sound very clever at home. But yeah, kind of just around this and obviously what we're saying when it comes to, representation and obviously emojis is part of that and representation as a whole. But from a kind of your journey into tech perspective, obviously being quite different and more of a career changer, was it something that, representation was a factor in your kind of career considerations more toward the start? So, do you think you would have considered a career in tech a bit earlier if there had have been kind of more female representation within the industry, or do you think it was just something that you kind of stumbled into?
Yeah, you're absolutely spot on, Alex. The lack of female representation was definitely a thing, definitely an issue. So when I think back to when I was choosing my GCSEs and choosing my A levels, IT, as it was known then, just wasn't a thing for girls, right? I mean, it was a thing for boys. And, it's a sad, sad thing, but I think anyone who's come through the British education system will probably say the same thing. And I have thought a few times since then, since doing my non-tech courses, my non-tech degree and stuff, a few times I thought, oh, I really wish I'd done computer science. I really wish I'd done coding. It looks really cool and it's what all the cool kids are doing and, it seems really exciting. But I just thought, surely it's too late now. I'm a historian, I'm halfway through another career. There's no way I can do it. And it was just a chance conversation with a friend of mine over dinner who said, she works in recruitment for American Express, and she said, we just cannot get female coders, cannot get female software engineers, cannot get female developers. You like spreadsheets, she said, you should give it a try. And I think, spreadsheets are a bit of a gateway drug, aren't they, for people coming into coding? I'm sure I'm not the only one who's come from a love of Excel into coding. And yeah, I think, there is still that problem, isn't there, of a lack of female role models. I love the classic phrase, if she can see it, she can be it. And how true is that? If you look around you when you're 16 and you can't see women doing tech, then, how on earth are you going to consider it as a career? I think it's just a lot less likely. So yes, I think it is a problem. It definitely was a problem back when I was considering my career choices. I think it's getting better, but I think it's still a problem now. And I think it's why events like this, like at the Athena Hackathon, are just right on the money. That was a very long answer, and I
No.
think to answer your first question, my family would probably say too much is how often I put hexadecimal into a conversation.
I think that was a great answer. And just to say to everyone that I promise we didn't pay for you to plug the Athena hack as part of that. That wasn't a planted question that we planned. But no, I think it is, just in general outside of Athena, even it's super important. It's like you say, getting better, but still work to be done, I think. And yeah, hexadecimal is an interesting one. But there's kind of a few people in the chat, I think, that have, given their answers to the questions. So I don't know if we want to kind of go through and crack on, or
Yeah, absolutely.
maybe
Yeah,
I'll fade back into the background.
I'll stop rambling on. Okay. So brilliant. Thank you for those answers in the chat. So hopefully you have come up with a farmer, a family with two mums and a little kid, and oh, it's behind me, but there, can you see that now? There is a black female astronaut down there in the corner. Fantastic. So we're coming towards the end now. So we've seen what emojis can do and where they're going. So is it helping? Does any of this matter? How important is it actually that there is an emoji for different skin tones? So a paper from the University of Edinburgh in 2018 studied the use of different skin tone emojis around the world, and it found that people do tend to use emojis that relate to their skin tone. So this rather complicated looking map shows the mapping between the skin tone of the user on the left and which emoji skin tone was most often used. The darker the box, the more often it was used. So if we look at the top left where it's dark blue, you can see that 1 corresponds to 1. So people do use the emoji that corresponds to their skin color. So again, down in the bottom right, you can see the darker skin tone users down there. So another thing that has come up recently, so sometimes campaigns for change try to gain awareness via emojis. So you may be familiar with the work of Plan International UK. They are a fantastic charity. Look them up if you haven't already. They're a children's charity who try and create a just and equal world for girls. In many parts of the world, there's a real stigma around periods and around menstruation, and it's wrongly seen as a very negative thing, and people don't want to talk about it. So Plan UK campaigned to have a period emoji put into the Unicode standard to help raise awareness and to help normalise discussion of periods. So this emoji, the drop of blood, was added in 2019. So I don't know if you're aware of this, but there's a committee of people, like a group of, I think, 10 people sit around a table. They are the Unicode committee, and they decide every year which new emojis are going to be added. So no new emojis are added without going through the approval of this committee. And different people, different groups can campaign to this or apply to this group to have their new emojis added. So for both of these things, adding more diverse emojis, some specific symbols to help raise awareness. I'm not saying it's going to fix society. You know, we are a long way off emojis being the answer here. But it can just be one tiny bit of pressure, a tiny bit of representation to help improve things for people around the world. I mean, representation and communication really do matter. There's nothing more to say than that. So thank you very much for listening. It's been a bit of a whistle-stop tour through emojis and hexadecimals and character encoding. I hope you're still following me. We've got some time for questions, so do pop them in the chat if you haven't already, and we can take some of those.
Yeah, thank you very much. I'm certainly wiser than I was at the start when it comes to Unicode and hexadecimal and coding and decoding. So yeah, thank you very much, and hopefully some others on the call are the same. As Jen says, if there's any questions, pop them in the chat and let us know, and we'll make sure that they get answered. I think I'll start off with one, and I think just kind of a general theme for the week, really. And I think, like you say, because of your career path, it's kind of a very interesting position to answer, but just whether I suppose there is any kind of like key piece of advice or something you would give to people potentially starting their career in tech, maybe as you know, kind of a female or non-binary. I think, you know, there's been kind of a lot said this week from different aspects, but I think a lot of the attendees are going to be kind of toward the start of their career, whether that's boot camp, whether that's uni, whether that's career changes. So I don't know if you have any words of wisdom, but it'd be interesting to kind of hear from you.
Yeah, sure. I mean, my overriding bit of advice really is just to enjoy it. Enjoy the coding you're doing. Find a bit of technology, or a language or a particular area of technology that you enjoy, something that interests you. Go with that, and explore it. And also, my second piece of advice would be that you are not expected to know everything. You are not expected to be an expert. So, I've recently, well, a year ago, joined this company as a junior developer, and I was so nervous that I had come out of this 6-month bootcamp course, and was I going to have been taught the right things? Was I going to know enough? Were they going to expect me to know everything in depth? And people really don't. Be confident about what you do know, be confident about your ability to learn and about your interest in the tech, and do not expect to be expected to know everything from day one. Is the sort of two pieces of advice I wish that I had thought of
Yeah,
more when I was joining.
I was going to say, I think that's great because it came up in one of the discussions yesterday, actually, I think around the kind of, yeah, the weird stigma you have when it's a job, and like it just everything seems so much more pressured, and so many feels like outside of work where you wouldn't be expected to know everything, or like you would know that you're just starting out or whatever. But yeah, when it comes to a job, you kind of think very differently about things. So yeah, I think that's a very good piece of advice, and hopefully something that people can follow. going into the weekend and throughout the rest of their careers too. Just looking at the chat, I don't know if there are any questions at the minute. So I think what we can do, I think for everyone kind of listening, whether it's afterwards, whether it's now and you think of something at a later date, is you can ask us questions on Discord if you need to. We're always available, and we can reach out to Jen and we can help and we can get those questions answered. So let us know on Discord if there is anything you think of. If you want to ask whether it's about emojis, whether it's about career, not to assume, Jen, but I'm sure you're more than happy to help and answer questions. So
Absolutely, yeah. And I'll be hanging around on the Discord myself in the if there's a BAE Systems channel, so I will be particularly keeping an eye on that. So if you have any questions, particularly for me, either about the company or just about changing careers or about being a junior developer and knowing too much about history to to wonder whether you can ever be a developer, then please do ask me a question.
And there you go, you've done my job for me as well by plugging the Discord channel. So yeah, go make sure you're on the BAE channel. The link to follow their hub as well is in the chat. So make sure you go and follow that for all the latest kind of updates. But to finish off, a huge thank you, Jen. It's been amazing having you here. Really enjoyed it. And a big thank you to everyone listening as well. So good luck and see you at the weekend, everyone.
Brilliant. Thanks for having me. Bye.